Okay, hi class, this is Mrs. Miller. I am doing a recording over the review since I am not in class today. And then you guys can listen to this at your leisure and hopefully understand the concepts that will be on the assessment that you are going to be taking in 2 days. So the very first question, you guys can read on your own, but the question that they are wanting for us to answer is right here at the end, what is the predicted value of her score on the exam? Well, remember the predicted value comes from the equation for the line of best fit, which is the least square regression line. So in order to calculate this, you're going to need to plug this into the equation. So the equation that they gave you was right here, computed to be this equation. This would be our y hat. Just doesn't have the little hat above it, but it tells you that it was their predicted test. So all you're going to do is take 10 and you are going to take plus 0.9 and you're going to plug in the value and find out what is the predicted value. So we're going to put 95 in there because that's what they ask us to do. And when you do this, you find out that your answer is D. Okay, that should have been pretty easy. The second one says that we're going to refer to this one, and she actually got a 98 on this test. So we have to calculate the residual. Remember, residual is the actual score minus the predicted score. So the actual score was a 98. Her predicted score that we just found in question 1 was a 95.5, which gives me a residual of 2.5 positive, because she actually did better than we thought she was actually going to do. So make sure you know that formula, actual minus predicted values. Number 3. Number 3 says, we're looking at our graph, and it says here's a pattern on our here's a residual plot from the least square regression line. What does the pattern of the residual tell you about the linear model? So looking at this, remember on a residual plot, do I want to have a pattern? Hopefully you're saying to yourself, no, you don't want a pattern. But right now I can clearly draw a pattern through this. So this tells me that this is absolutely not going to be linear. So D says that the residual plot clearly contradicts any linearity of the data. It's contradicting that it's going to be linear. That's what linearity means. Okay, looking at 4. All of the following statements contain a blunder. Which statement does not, aka is correct? So we'll just go through each one of them because sometimes that's easier for you to identify the blunders. The first one is, there is a correlation of 0.54 between the position a football player plays and their weight. So remember, if they're saying that there's a correlation between their position and their weight, and a 0.54 means that it's going to be a positive correlation, is that a true statement? The problem with this statement is that we are talking about the position that a football player plays, and that is not quantitative, that is categorical. So this one is incorrect because it is talking about categorical data, comparing it to a quantitative data of their weight, and that's not correct. Okay, so B says the correlation between planting rate and yield of corn was found to be R equals 0.023. So do we expect, first of all, are these two quantitative data? So we've got planting rate and the yield of corn. They're quantitative, so we're okay with that part. And it's a low correlation, which makes sense because really, does it matter how fast you plant something to how much corn you're going to make? Not really. So far that one actually seems to be the most correct. C, the correlation between the gas mileage of a car and the weight of a car is 0.71 miles per gallon. Does the weight of a car and mileage make MPG? Hopefully you're saying no, MPG is miles per gallon, not mileage per weight. So this is my problem right here, is they're using the wrong statements. Okay, so let's look at D. D says we found a correlation of 1.08 between the height and age of children. Can we have a correlation of 1.0, not 8, 1.09. Can we have a correlation on R score above 1? No, we cannot. Finally, we found a correlation of R negative 0.63 between gender and political party. Gender is categorical, political party is categorical. So those are problems in that one as well. So our best answer is B. Okay, next slide. Number 5. A study found the correlation to be R equals 0.61 between the sex of a worker and his or her income. You conclude that women earn more money than women earn less money than men. An arithmetic mistake was made. It's not possible for R. Or D, this is nonsense because R makes no sense here. I will tell you, I think it would be okay. Well, no, it's not. Okay, let's just look at this. So if we talk about gender of a worker, we're talking about male versus female. And then the income is quantitative. I can't compare these on a scatter plot because we're talking about categorical here and we're talking about quantitative here. So we need this to both be quantitative. So we can't even determine about the men and the women thing. And then the arithmetic mistake was made. This is not a possible R value. Well, we can have an R of 0.61, so that's not really the problem. The problem is that we can't even calculate an R because it doesn't make sense here when I'm using categorical and quantitative variables. Okay, number 6. I told you that we would possibly, if I ever asked you to calculate one of these problems, it would be in the sense that I gave you all of the numbers and you would literally just have to plug them into the formula sheet. So in order to plug this into the formula, you are going to need to know the formula, which is what we wrote down in the last class, but it is on the formula, it is on the AP worksheet. I will tell you, and I want you to rest assured with this, is I'm actually not going to ask you this one on the test because I'm not expecting you to memorize the formulas or use the AP formula sheet yet, but I will show you right quick that B is R, standard deviation of X, standard deviation, oops, that's standard deviation of Y over X. Sorry. R, standard deviation Y over the standard deviation of X. So all I'm literally having to do on this problem is plug and chug. So they told me that R was 0.86, and then we have 3.8 is the top number and 2.1 is the bottom number. I do this math and I get a final answer of B. So this is really just a plug and chug. Okay, number 7. 7, in the setting of the previous problem, what percent of variation in the number of service hours is explained by the linear relationship between service calls and the number of machines? When I'm asking for percent of variation, I'm talking about R squared. That is literally the definition for R squared. So in the previous problem, they told me that R is 0.86. So to calculate R squared, I literally have to square both of those numbers. And that gives me C. 7. If a data set A of XY data has a correlation coefficient of R and the second data set has a correlation of negative 0.65, then we'll look at the differences, guys. These two numbers. They're the exact same number, but yet one is positive and negative. Does that make the association any stronger or less stronger? No, it's the same strength of association. It's just one has a positive association, one has a negative association. So that means that A and B won't work because it says that we're going to talk about stronger or linear, or which one's stronger. They're both the same. And then D says you can't tell which data set has a stronger linear association without seeing the data. Well, we can. We saw the R values. So since they're both the same, neither of them has a stronger linear relationship because they're identical. Okay, number 9. There is a linear relationship between the number of chirps made by a striped ground cricket and air temperature. The least squared fit least squares fit of some data collected by a biologist gives the model of y hat, blah, 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 between 9 and 25. Remember, X talks about the chirps per minute, and y hat is the estimated temperature in degrees. What is the estimated increase in temperature that corresponds to the increase in 5 chirps? So if I'm going to increase something, if I'm increasing where X says the number of chirps, I'm increasing this. They want me to know what is going to help in what's going to happen to my temperature. Does it matter where I start? Does this B or Y, well, I'm going to call it B, it's y-intercept. I guess technically it's A and ours. Does that y-intercept make a difference on where I start when I'm talking about the word increase? Hopefully you're like, well, no, it's just you can subtract the difference. So really all I care about if I'm doing this is to take that slope and multiply it times that 5. And by doing that, I'll know what the increase is supposed to be added to 25.2. It's not asking me what my final temperature is going to be. It's saying what's my increase going to be. So I just need to do the multiplication in order to find the increase. So read carefully. 10. The equation of the least square regression line for the points on the scatter plot is this. What is the residual for this point? So if I give you the least square regression line and I gave you a point, this is my actual data. So we need to find out what our predicted would be. So I'm going to take the x value and I'm going to plug it into my y hat equation. So 1.3 plus 0.73 times 4, because that's my actual data I'm plugging in here, gives me a predicted value of 4.22. So then remember, to find a residual, I'm going to say actual minus predicted, and my actual was 7 is my actual, because that's what we found it to be, and then my residual was 422, and so that gives me a final answer of A. So even just giving you a point and a predicted line, you should be able to finish this problem out. 11, a linear regression usually employs the following, or the method of least squares. Which of the following quantity is minimized by the least square regression line? So I'm not even going to expect this from you guys, but the answer should be C. It's the top of the formula if you go back to the notes that were recorded in 3.2. But again, it's not an expectation for you guys to know that. Number 12, a set of data relates to the amounts of annual salary raise for a performance rating. The least square regression line is this, where y is the estimated raise and x is the performance rating. Which of the following is not correct? So let's look at A. A says for each increase of 1 point in performance rating, the raise will increase on average of $2,000. Well, y is my top. They're talking about slope here, and we know that slope is y over x. So I don't go over one rating. I don't go one rating up. I go one rating over is what I should be doing. I should be doing y over x, not x over y. So the problem with A is they backwards. Okay? B, the equation produces predicted raises on average of 0. No, y hat is my prediction. And it's not giving me an on average of 0 because that would be saying that, that I have no change. But I am having some change. So that can't be it. C, the rating of 0 will yield a predicted raise of $1,400. The rating of 0 is my x, and it would give me that. That's my y-intercept. So that is correct. We're okay with this one. Oh, I think I just messed something up. I just realized it's talking about it's talking about which one isn't correct. And actually I'm okay with some of these. So this one is okay. The correlation of the data is positive. Well, the slope is positive, so yeah, we're going to say that that is correct as well. So this equation, I'm going to go back and look at A, because I marked that one out for sure, but maybe I'm confusing myself. For each increase of y point in performance raising, so they're saying going up by 1, the raise should increase $2,000. But the raise should be 2,000. When we're talking about slope, we're talking about 2,000 to 1, which would mean that my change in y being the estimated raise, for every $2,000 I go up for an increase in performance point, which is correct. I did confuse myself. I apologize. So far, actually, they're all correct, which means that my final answer should be E. That they all good. Okay, sorry if I confused any of you guys. I'm glad I was able to get through that so that you guys could see through the thought process. Okay, so 13, which of the following would not be a correct interpretation of the correlation of R equals negative 0.3? So would not be a correct interpretation. The variables are inversely related. That's true because by saying the word inversely, they're saying that there's a negative relationship. For R to be negative 0.3, that is negative. B, the coefficient of determination is 0.09. Remember, coefficient of determination is R squared. So we need to see what R is, and we need to square it, and that gives me 0.09, so we're good. C, 30% of the variation between the variables is linear. We're not talking about the variation, really, we're talking about the fraction of variation between the two variables. And we're saying it's not between the variables, it's saying that the line of best fit can explain that difference. So really, this one is not word for word like we're looking for. D, there exists a weak relationship between the variables. I would say negative 0.3 is fairly weak. So yes, that one's true. And E, all the above statements are correct. Well, that's not true either. So I guess technically you could pick that one, but it's not. C is the one that is definitely incorrect. Okay. 14, the following are resistant. When they say resistant, they're talking about to outliers. Is the least square regression line resistant to outliers? No, it's definitely not resistant to outliers, which means the correlation coefficient is not going to be resistant to outliers. Both the least square regression line and the correlation coefficient are resistant. Nope, that's not true. So the final answer is D. Okay, so now I'm going to start on the free response stuff. So looking at this, we have some data points. We have my X data points is time, because time would help tell me what my speed should be. So I've got my first list and my second list, and it says, is there an explanatory response variable? If so, which is which? So I would say the explanatory should be time, because then that can help tell me what my response is, since distance equals rate times time. And this is my speed. Okay? So 2 says make a scatter plot of the data and don't forget to label your axis. So we're going to have time down here. I'm going to do this quick. Speed here. And you're going to just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And maybe we go by 0.2. So 0.2, 0.4, 0.6, 0.8. And then we're just going to come in here and we're going to plot. There's one at 0, 0. There's one that looks like it's going to be around here. There's one that looks like it's going to be partly up. We've got one just over 6. And then finally we've got one in here. So that looks like it's a pretty linear pattern. So number 3 says, is the positive or negative association between these? Well, this is positive. And why do we know this? Because as time increases, so does speed. Okay? So if there's an association between time and speed, then describe it in a sentence. Oh, I just kind of did that. So let's take all this stuff, and this can go in here. Number 4, identify any regression outliers. I would say there doesn't appear to be any. So I guess I can write all this out, but there doesn't appear to be any. Okay, if there's an association, is it strong? Oh, it is strong. Would we be willing to predict the speed at 1 second? Well, since 1 second is not far from where we left off with the speed of 0.8 seconds, then I would say we're okay with that. It is not an extrapolation. So I would say, yeah, we could actually do this. And when you plug this into the equation, when you calculate it, you should be able to get that it is about 10 meters per second. So should I go through how I actually calculate this? I'm not going to on this problem. I'm going to do it on the next one since there's more data points. This was basically, can you do this kind of information? So hopefully that made sense. I went through that one fairly quickly. Let's look at the second one. Oh, that's not my second one. We'll look at that one, and then maybe I'll do it on the last one then. Okay, so the second one says, we've got a whole bunch of information here. It says the table, there's some evidence that drinking moderate amounts of wine will help prevent heart attacks. The table gives data on yearly wine consumptions, so liters of alcohol from drinking wine per person, and yearly deaths from heart disease in 19 different nations. So we've got some varying degrees. I like how you notice that France is the most wine, and they do drink a lot of wine. And then there's some that just don't drink much wine at all. So make a scatter plot that shows how wine consumption affects heart disease. Label the HD deaths axis from 50 to 300 with increments of 25. So that was nice that they gave us a little idea of what to do. So HD deaths, and we're going to go by, like they said, from 50 to 150, 200, 250, 300 should be good. And then the amount of alcohol is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is alcohol. For wine, liters, I guess, technically. Okay, and so then I would just plot all my points, and you should get something. These are not exact, but I did this on my own paper, so it's going to be something like this. I'm just going quickly. So how would I describe this? This is that description that we have to remember. DOFS. What's my direction? It is a negative. Form is linear. And I would say it looks moderately strong. It looks pretty strong to me. So we're going to say moderately strong. Okay? And then outliers. Does there appear to be outliers? Honestly, it doesn't really seem to be outliers, but we don't know that yet. So not known yet. Or you can write down, I'll even erase that. Maybe we'll say doesn't appear to have any. We don't know this for sure yet, but we are going to just make a statement that we don't think it has any yet. So is the direction of the association positive or negative? We already kind of said this. So it's a negative association. C says explain in simple language what this says about wine and heart disease. So in simple language, not in statistical terms, as wine consumption increases, heart disease decreases. I would think somebody who's even drinking would understand what that means, which means it's simple enough language, apparently. But don't drink. I do not think this data is entirely accurate in my opinion. Okay, Number 9, calculate the correlation R and how strong is this relationship. Now, we could sit here and actually calculate it, but what you should do, and I will try to quickly do this in my calculator, sitting at my desk, is I would get my calculator out, start a new document, and I'm going to do a list and spreadsheet, and I'm going to put in my alcohol, because that's what they told me was the first one. I totally spelled that wrong. And we'll call this HD for heart disease. And this is going to take a little bit, but, oops, 2.5, 3.9, 2.9. I'm going to pause and do this. Okay, so I'm back. I just put in all the data. And so now I'm going to sit here, come up to this page. And since I'm only asked for R right now, I'm just going to calculate the R in this page. And so I'm going to go to statistics, and I'm going to go to 2 variable. No, we'll do linear regression. It's fine. Let's change this to the alcohol. We'll change this to the heart disease, and we're going to say it's okay. And so down here, it tells me my R is negative 0.84 or 85. I'm sorry. So that's the R that we found. Now I could sit here and actually create another page, and I'll put the alcohol down here so we can make sure that our graph looks correct. And so that's kind of what I was trying to do with my dots. And so there's all my dots in here. And you can see that doesn't look like there's any outliers here. I would take the time to plug these in just to verify that you do have a fairly strong negative linear association with minimal outliers. So let's look at the R. I'm going to, whoops, wrong thing. Coming back here, it said that my R we found out was negative 0.85, so I would say that's pretty strong. And so then the bottom part says, explain why your R value is reasonable based on the scatter plot. So maybe we write down something like the correlation will have negative sign. Why does it have a negative sign? Since it's going downward, since the data moves downward as we move right to the right, okay? And then there is a fairly strong, maybe we talk about even the number being as strong as it is. So there is a strong relationship with the points, and you could say something to the effect of, if you want, they are clustered around, maybe even tightly around the line. So we should be good with that. So we knew it was going to be tight around the line, and we know it's negative, so that's going to be why it's so high. Okay, last one. This is the weights of children in an Egyptian village were recorded. There are mean weights of 170 children in that village. So we did the ages. This is the average weights of the different age ranges. So this wants me to actually calculate everything. So I'm going to go back to my document or my calculator, and we're going to have to start a new document, and we're going to plug everything in again. So I'm not saving this. I'm going to start a list and spreadsheet. I'm going to put age in here. I'm going to put weight in here. And I'm going to put in my months. And then I'm going to come over here. And I'm going to plug in my weights. 4.3, 5.1, 5.7. So it's super exciting recording right now as I'm sitting here plugging in points. Ooh, there's a lot of 7.2s. And now that I have my points, I'm going to sit here, and it says they want me to calculate. Number 1 says make a scatter plot of them. Don't forget to scale it. So in that first box, I'm not going to sit here and redo it again for the 100th time, but I'll add another page, and I'll show you your scatter plot should be age is your explanatory variable, weight is your response variable. Your scatter plot should look something like this. It kind of comes up and it swerves. That's actually not a really good linear model, I don't believe. So let's go back to my page, or we could do it in here. That's fine. If you want to, it says determine the equation of the LSRL and what is the correlation. Well, I can only determine if I hit menu, analyze, regression, show my ABX. Here's my LSRL, but it doesn't tell me R. So I actually have to come over to this page and I need to calculate. Let's not do two variable. Let's do, God bless. I picked MX plus B. I'm going too quick, sorry. Stat calculations, A plus BX. So we're going to put in age here, since that's my explanatory, weight, which is my response, and we're going to say okay. What did I not hit? I don't know what oh, it's up higher. Hello. You can tell I'm getting tired. Okay, so it's up here. So here's my A and my B to write my equation, and then my correlation looks like it is 0.91. So that's a fairly high correlation here, which makes sense. So I'm going to come back over here, and I'm going to write down my equation. So again, it said my predicted value for weight, this is my y hat. I'm just already going to put in my categories so that I can know what everything is rather than having to identify. And remember, if you use X and Y in there, you really do need to identify what your X and Y is. And over here, this is my scatter plot that we did in the calculator. I will tell you on the test, you're going to have to draw one, but I'm not going to redo it right here. But we know that it did something like, kind of did this kind of thing in there. Okay, so then it says plot the line on your scatter plot. Don't eyeball it, actually draw it. Well, I gave you the line, so you should be able to put that in there. Then it says, tell me some points that you use that will best fit this line. Well, one of the points that would probably best fit the line once you draw it in there for real is 1, 5.15. And then another point that really goes through the line when you actually do it is the 12. Okay, so then down at the bottom it says it wants me to calculate the residuals and add them to the table above. Use the second grid to provide to construct the residual plot. So the residual plot, I will draw this one real quick. Remember, a residual plot has a 0 line, and then I've got positive data above it if my residuals are positive, and I got negative residuals below it. Okay? And so when you do this, and I'm going to go back to the calculator page so that you can see it actually being done. Remember, if I'm on this page, I can hit menu now that I've done regression here. Now residuals is lit up. So I'm actually going to choose show the residual plot. And by choosing to show the residual plot, you're going to see that I've got this kind of swoopy pattern listed on my graph. So coming over to my Smart Notebook page, my residual plot will look something to the effect of, and I'm kind of guesstimating this right now, I'm not going perfect. You can do this better when you've scaled it. But we saw that it looks something like this. Since we can clearly see a pattern, we can say, number 16 says, use the residual plot to answer the question, is a least squared line an acceptable summary of the overall pattern? Explain. So the LSRL is not a good fit for the data. And why is this true? This is true because even though there's a strong association of 0.9, there is a clear pattern in our residual plot indicating that a linear model is not appropriate. Now, In a more advanced statistics class, you're going to learn what kind of models, there are other types of models. We're not going to do that. So that is enough for, I believe, the review. Hopefully this made sense to you. I will tell you, as you probably tell from the review, a lot of this test is going to be using the calculator and just interpreting what's going on in this. So make sure you know your vocabulary words, make sure you know how to use the calculator. As stated before, I will be available for assistance on Tuesday after school, and of course I'll be here Wednesday before school, Wednesday after school, Thursday before school, and then you have your test. I was reminded that we have a late arrival on Wednesday, so that means that lab is not available. I'm sorry for that, but for whatever reason, every time we turn around, something's happening to lab. So anyway, good luck and come in for help if you need help.